So the organization of the microprocessor, you can able to see that here. A microprocessor is just like a electronic chip, and which is also a more powerful than any other chip here. So here a microprocessor to be a device that it is a programmable logical device. And it has a limited set of on-chip memory locations, and which are known as registers, and which can hold the information. And to understand a fixed set of basic commands, and it can generate signals to control external devices. So you can easily observe that microprocessor. When do you say this is a control processing unit, central processing unit? So CPU means here which contains ALU, arithmetic logical unit, register arrays, as well as the control unit. So the combination you can call it as a CPU, and which may be bidirectional connection. Input and output devices and system buses are there, and there only memory is also included. This memory is read-only memory as well as the random access memory. Read-write memory. Okay. So this ALU, last class we have been seeing that. So arithmetical logic in address buses are there. Elaborately, data bus, control bus. Yeah. ALU. So arithmetic logic unit. So this is the which includes the microprocessor, and the performance of this ALU is that it is going to be computing and functions which are performed by the given data. So the performance of this ALU is that addition, subtraction, logical operations, such as AND here. AND means multiplication and dot product, or summation, exclusive or XOR gate, and results which can store either in registers or memory, or which can be sent to the output devices. Okay. So what is the register unit? The register unit, which may have the area for the microprocessor, which may contain various registers, and these are going to be performing to store data temporarily during the execution of the program. Okay, not permanently, it can store the data, and so the results, that means some of the registers which are accessible to the user through the instructions. Okay. And next one is the control unit CU, and this may provides the necessary timings and control signals to all the operations in a microcomputer, and it can controls the flow of the data between the microprocessor and peripherals. Peripherals, which is input and output devices. Okay, peripherals are. So at the outset, we will differentiate between the microprocessor and microcomputer because of the common misuse of these terms in popular literature. The microprocessor is one of the component of the microcomputer. In another hand, the microcomputer is a complete computer. Similarly to any other computer, except that CPU functions of microcomputer, and which can be performing the here microprocessor. So the peripherals which are used for input and output devices, peripherals. Occasionally, memory is also included in this. The various components of the microcomputer, which is going to be describing here. What are input means? The input section, which may transfer the data and instructions to the binary form and the outside the world to the microprocessor. Okay, so it includes the keyboards, cell types, and analog to digital converters. And microcomputer used in college laboratories, including either hexadecimal keyboard or ASCII code. So American Standard Code for interface. Uh, so information interfacing here, which is a keyboard for the input device. And the hexadecimal code, hexa means 16, which may have 0 to 9 after 10, A to F. Okay. So 10 may be represented A, 11 is B, 12 C, 13 D, 14 E, 15 F. Like that, we are going to be representing these hexadecimal codes. Okay. So ASCII code is the uh, which is a typewriter keyboard, and it is used to enter the program in English language. Okay. So what are the outputs means you know pretty well. The output section which can transfer the data from the microprocessor to the output devices, such as LEDs, CRTs, key CRT cathode ray tubes, printers, magnetic tapes, and another computer. So single board computer which includes LEDs, 7-segment LEDs, output device, memory. Memory stores binary information, whatever the data you are giving, like words, charts, pictures, numbers, whatever it may be. The computer itself, it may be converting into zeros and ones. Then only the information which may be stored inside the memory. Okay. So here, which may provide the information to the microprocessor, whatever the necessary is. Whenever you are going to execute the programs, microprocessors reads the instruction and data from memory and performs the computing operations in ALU section. Computing means addition, multiplication, logarithmic operations, all these things. Results are either transferred to the output section of the display or stored in the memory. Okay. So the memory block diagram below is there, and it has two sections. One is the RAM, random access memory. Another one is the ROM, read-only memory. Okay. So first of all, we should discuss ROM. Not if this is a RA, print mistake. Okay. This is ROM. ROM. Print mistake. ROM. So this is RAM. Print mistake is there. You can correct it. So ROM is used to store the programs, and no alteration is made by this. The monitor program of a single board microcomputer, which is generally stored in ROM, and the program which may interprets the information and which is entered through a keyboard, and which can provide equal binary digits to the microprocessor. Once the program is stored in ROM, it can read only, and no alteration is done on this ROM. Next is the RAM, that is to the read or write memory. which is also known as a user memory. You can store the data by using the program, and in single board computers, microcomputers, the instructions and the data which can be altered so that you can easily enter through a hexaboard. Monitor program monitor is the keys and the instructions, the and data in the read write memory. So here the information stored in this memory, which can be read and altered easily. Okay, different programs we are using there only. We are, if you want to perform any operation by using this program, you are doing some calculations, all these things, so that whenever you are getting a wrong, or if you type it wrong, you can easily remove and you can easily alter, change in the case of RAM, not in ROM. Okay, remember it. Next is the system bus. So in system bus, system bus is a communication path between microprocessor and peripherals. Peripherals is nothing but IO devices, and it is nothing but a group of wires and carriers, the bits here. Microcomputer bus in this many ways similar to one track. Express subway, the carries the bits here. Bus is going to be carries the bits. So just as the subway carries the people here. The analog of an express subway with only one destination is more appropriate that of a regular subway. So microcomputer bus carries between bits between microprocessor and IO peripheral, one peripherals, and timing which is provided by the control section of the micro. Next, instruction language is programming. You can go for the machine language. So the each microprocessor has a unique set of machine languages, which was defined by the manufacturers, not by the human customer, whatever it may be. Okay, they have been purchased. Those are not going to be write the machine language. Who is the manufacturer? That person is going to be write the machine language. So that is only going to be executed here. So each instruction in machine language normally consists of strings of ones and zeros, and it is very convenient for the programmer. He can easily remember all the instructions in machine language. So in order to prove the programmer's efficiency in writing in machine language programs, hexadecimal numbers, which are rather than the binary numbers, which are used for instructions. It is relatively easier to detect errors, hexadecimal digits, rather than the skills of binary numbers, running up to 32 to 64. So these machine language instructions, which are not common to all the microprocessors. So each and every microprocessor has its unique instructions. Okay, unique language. So you can go for one table, hexadecimal. This is the machine language. This is the hexadecimal code, hexa code. So this is 30111. So 0111. what it is. I already told you how to convert. 0, 1, 1, 1. 2 4 0, 2 4 1, 2 square, 2 cube. That is not correct, I think. 0, 1. That is 3. So 1, 0. Like that. Next, another important one is the assembly language problem. ALP. Important. So the mission language program, which is very inconvenient and difficult to the memorize in assembly language program, and which can be developed. It consists of certain memories which are very close to the English language words, and the operation of the microprocessor is supposed to perform by you writing all these codes, everything. So here the translation of the operation codes, op codes, okay, operational code, open. So in machine language in hexadecimal form, which can be done directly by the programmer with the help of the set instructions set along the microprocessor. So here hexadecimal numbers which can be carried by an assembler and which can store memory automatically and which can transfer these memory into opcodes. Source code is assembly language or high language. So translator which may translate the source code is assembler or compiler. What is the object code binary machine language? So what is the high level language? Even though the programmer's efficiency, it can improve slightly with the programming in assembly language compared to machine language program. The programmer, he can acquaint with the architecture and the instruction set of microprocessor. So this is the assembly language code, HLT, binary form of ASCII codes, as seen by the assembler is 0100 1000. So what are the opcodes created by the assemblers? This one. So you can go for one program here. In label start, mnemonic and operator comment. So MVI operand is A comma 10H. Immediately move, MVI means immediately you can store 10H hexadecimal number into register A or register accumulator. Okay. Accumulator is nothing but a register. That is A. So there only move immediately. Immediately you are moving the 10 bit of hexadecimal number into the register A, accumulator. Next, ADI 20H. Add 20H to content of the accumulator. Already accumulator which contains the 10 and you are adding 20. Next, LXI H 20. So that loading the register pair with. What you may get here? 10 plus 20, 30 you will get. This is wrong, print mistake. Okay? 030. Next, move A comma M. So 30 is available in the accumulator. That 30 which may be into, you are moving the content of the accumulator into the here location M. Okay. Next jump condition. Start. That means again you are starting this process. So that in accumulator or whatever the register is going to be considered, immediately two numbers you are considering, adding. Okay, if the process is not done properly, again you can start it. That is the case. So in PG and in UG also, in electronic students, there you may find out this. Okay, 8085 architecture. Nowadays we are using Pentium 1 to 4. So it is very tedious process for the programmer to write all these steps for a simple addition. So and high level languages, basic, Fortran, COBOL, C plus C language, which was developed. So the programming becomes very simple, and a single instruction in a high level language which may corresponds to the set of instructions in assembly or machine language. So in order to, we are given the instruction at high level language, which is a set of instruction in the assembly or machine language. The compiler are nothing but a software programs and the high level languages. These are mission independent, which is highly advantage in future. You can go for start. Next is start the problem. Develop the algorithm. The algorithm which may includes the different codes into suitable programming language, MLA, LHL. Next, get the program translated into ML if it is necessary. Enter the ML into the memory microprocessor. Next, start microprocessor to execute the program. Next is the examine the result. Examine results. If the results are okay, end the program. Or else modify the algorithm. Again, feedback to the input here. So programming of microprocessor. The total instruction set of microprocessor 8085, which are classified into 5 groups. One is the data transfer group, arithmetic group, logical group, branching group, stack, input, output, and mission control. Hmm. So here start the problem clearly and develop the program algorithm in the best possible way. Flowchart. Next, the set for test for any logical or synthetic errors and diagrams. Box is for run the program. So this is the architecture for microprocessor 8085. I will play you one video regarding to the architecture of the 8085 microprocessor. Hey. Video నడుస్తుంది. So this is the architecture for the 8085 microprocessor. Uh, you already seen this with the video representation. Address and data and address buses. Next is the data and address buses. Data and address buses. Data bits were from the microprocessor D0 to D7, and 8-bit of the information which you can easily transfer. Uh, Whereas and the same 8 bits of same address are transmitted on the 8 lines, which are data are also transmitted AD0 to AD7. And the most significant bits, MSB, 8 bits which are sent on address lines A8 to A15. So that here 8085 has a 16-bit address transmission capability. So here addressing IO devices, memory mapped IO device. Registers in 8085. 8085 are the several registers during the execution of a program, and we can describe the size and use of these registers. So accumulator is one of the important register in 8085. This is 8-bit register which can be used for various arithmetic and logical operations during the addition of 8-bit integers operands like this. What are the registers labeled here? B, C, D, E, H, and L. Just now already everything we have been discussed. Okay. What are the applications of the 8G microprocessor? Microprocessor, which is extensive application in laboratory, industries for measurement and controlling various parameters, biomedical fields, automatic patent monitoring system, scanners into ICUs, home appliances like microwave ovens, washing machine, television set, CD player, musical equipment, music synthesizer, desktop publishing, data acquisition. All. So, what are the questions which have been given? What are the functional blocks in a microprocessor? 808. Next line. Discuss the functions of each block of a micro. Okay. So this ends our chapter. Next one is the modulation and demodulation. Like AC education.
అంటే ఒక 2-3 డేస్ అయింది ఏసీలో ఉన్నాను.